Hey guys, this is Mr. C, and in this video we're going to be solving some absolute value equations. And so I have a very simple one here to start out with. First, we know what absolute value does. Absolute value takes a number inside the absolute value bars and it turns it into a positive number no matter what. So if it's a negative number in here, it's going to pop out as a positive. If it's zero, it'll still be zero. But if it's positive, it's going to stay positive. So if we think about this equation, you have the absolute value of some unknown number equal to 5. So if we think about that, we know one number, it can definitely be 5, right? So it could be 5 because the absolute value of 5 is 5. However, if we think a little harder, negative 5 would also work because the absolute value of negative 5 is also 5. So the issue is we have two numbers in here that are both solutions to this equation right here. So either the positive one or the negative one. And so what we have is we have two equations. The first one, x is equal to 5. But the second one, everything in here could be negative too, right? And still be 5. So we have a second equation. The negative of everything in here could also be equal to 5. Now, if I look at the second equation, this one's no big deal, but the second one is a little awkward because we have that negative in front of the x. So what we usually do is we divide both sides by -1, and then it turns out that x is equal to -5. So here's what we do. And I should have written a +5 right there. Okay, so here's what we do. We go ahead and instead of writing x equals 5 and negative x equal to 5, we usually put the negative with the other side. So when I look at an equation like this, it's an absolute value equation, what I usually do is I write the first one, I remove the absolute value bars, and I just take the equation as it is. And we get our first solution just like up here after I fixed it. And the second one, instead of making the x negative, we just make the other side negative because that negative is going to move over anyway. So what we do then is we just take whatever's inside the absolute value bars, just remove them, and we set that equal to the negative of the other side, like that. And so we get our two solutions that way. So let's see what this looks like with a different problem. So now we have absolute value of x plus 1 is equal to 4. So we're going to get two solutions. And so we have two equations. The first one, we remove the absolute value bars. And then the second one, we remove the absolute value bars, but we set this side equal to, well, we don't set equal to, we just make it negative. So -4 for that one. And so we have two one-step equations, -1, -1. So x is equal to 3, -1, -1, and x is equal to -5. And so we get our two solutions of 3 and -5. Okay, in this one, we're going to do the same thing. Matter of fact, we're going to do the same thing every single time here. Okay, first one, remove the bars and solve it as is. The second one, remove the bars, but make that 9 over there a -9. Now, the reason why I write the two out first is because I know a lot of students will write the first one out and then stop, and then they always get half credit. And so you do want to have both of them already shown, so that way you know you're going to have to solve two equations and to get two solutions. So +7, bring down my 2x, 9 plus 7 is 16, divide by 2, and the first solution is 8. Second one, add 7, bring down my 2x, -9 plus 7 is -2, divide by 2, and so x is equal to -1. So let me stop there for a second. What if that was a -9 right here at the very beginning? What would happen if that was a -9? If that was a -9 at the very beginning, everything in here is going to pop out as a positive, or possibly 0, but it's going to be a positive in this case. So if that was a -9 right there, that could never be a negative. And so if you get a negative here, and that's the only negative in your problem, there's no negative there, but there is one here, or vice versa. If there's one here and not one there, then that would be a no solution problem. And you're going to see those as kind of tricky problems from teachers and professors. So in this case, though, we're good to go. We have a positive 9. There's a plus in front of here, and so we're fine. All right, next example. Again, we have two equations. 3x plus 4 equals 14, and 3x plus 4 equals negative 14. And then we just solve them. So minus 4, bring down my 3x, and that would be 10. Divide both sides by 3, and you get 10 over 3. I don't want to divide that because 3 doesn't go evenly into 10. As a matter of fact, it's going to be a repeating decimal. So I'm just going to leave that as 10/3. I'm not going to turn that into a mixed number because it's not going to do me any good. Even though you use them a lot in 7th grade and 6th grade, we're just going to leave that as an improper fraction. Over here, same thing, bring down my 3x. Negative 14 minus 4 is negative 18. Divide by 3. And we get x is equal to negative 6. So those are our two solutions. So yes, fractions as solutions are very common. If you want to test these two numbers to make sure that they're correct, you can plug them back in for that x right there individually and make sure that when you simplify this, you do get 14. All right, so here's our next one. X plus 9, absolute value is equal to negative 1. So here is equation number 1, equation number 2. So we have x plus 9 equals negative 1, and x plus 9 equals positive 1. So subtract 9, x is equal to negative 10. Over here, subtract 9, and x is equal to negative 8. So let's go ahead and plug those back in just to make sure that they're correct. So let's plug in the negative 10 first. So negative 10 for x plus 9 is equal to absolute value of negative 1 is equal to 1. I have a problem because that's a 1 and that says negative 1. Let's go over here to this one and see what this one looks like. Negative 8 plus 9, that's going to be equal to absolute value of 1. Let's make that look like a 1. And that is also 1, not negative 1. So what's happening? Well, let's back up about a minute or two and remember what I said before. You have the absolute value of an expression equal to negative 1. That is not going to happen. This is all going to pop out as a positive number or possibly 0, but it's not going to be negative 1. So unfortunately, this problem right here was kind of doomed from the start. It is not going to have any solution. However, what am I going to see on tests and quizzes? These two answers right there. And the reason why is because students are going to forget that this is a problem as a concept, and they're going to report these two answers like this in curly brackets, and it's going to be minus 10 on a test or a quiz because neither of those were actual solutions. So what is it? It is no solution, or you can write the symbol for the empty set. So be very careful on this one. Keep on the lookout for negative numbers on the right-hand side of an equation. All right, let's take a look at this one. Kids all the time are going to say, students say, distribute the 3. I don't like to do that as a practice. Even though in this problem, it's probably not going to affect me too much, I don't like it. And so what I want to do to get rid of that 3 in front, I want to go ahead and divide both sides by that 3 to get rid of it. Like that. Now it cancels. I bring down my 4x plus 5, absolute value, equals 7. Okay, now I'm good to go. First one, second one. 4x plus 5 equals 7, and 4x plus 5 equals negative 7. Okay, let's keep going. Minus 5, 4x is equal to, looks like 2. Divide by 4, and you get x is equal to 2 over 4 is aka 1/2. There's one solution. Subtract 5, bring down my 4x, and that will be negative 12. Divide by 4, and I get x is equal to negative 3. Again, when there's any doubt, plug these into the original equation, which I've kind of messed with here by dividing the 3 out. But plug them into the original equation, and you should get a true statement for both of them. All right, our last example, how bad this can be. You have 2 times all of this in absolute value, plus 4 is equal to 15. Before I even get started with 1 and 2 here, I need to get this guy by itself. And so I need to unwrap this just like I would a linear equation. So I'm first going to subtract 4, like that. I'm going to write 2 times 2x minus 1 equals 15 take away 4 is 11. And now I'm going to divide both sides by 2. And about this time, students will call me over to their desk and say, I did something wrong. I'll say, why? Well, I did something wrong because I got 2x minus 1 equals 11 halves. And I'm like, well, you didn't really do anything wrong. What's going to happen is you're going to get some fractions because this turned out to be a fraction over here. And that's okay. You're going to get fractions. So we're going to stick with the plan. We've got 2x minus 1 equal to 11 halves. And the second one is 2x minus 1 equals negative 11 over 2. All right, I need to solve these 2 equations. What I'm going to do is I'm going to multiply everything by 2 here. Times 2, times 2, times 2. So watch this. 2 times 2x is 4x. 2 times negative 1 is negative 2 equals 2 times 11 halves is 11. That 2 goes away right there. Add 2 to both sides. Bring down my 4x. That's going to be equal to 13. Divide by 4. And I get x is equal to 13 over 4. Okay, it's a fraction, but at least I didn't have to start, dividing and adding fractions over here. I'm going to do the same thing over here. Multiply everything by 2 because that's the denominator. So I get 4x minus 2 equals negative 11 this time. Add 2 to both sides. Bring down my 4x. Negative 11 plus 2 would be negative 9. Divide by 4. And I get for this one, x equals negative 9/4. So now I have 2 solutions. I've got this one right here, which I box in so my teacher can see it. And I box this one in so my teacher can see it because I've got a lot of other stuff up here and I don't want them having to hunt around for my 2 answers. They're right there. All right, guys, so this video explains how to solve some of these kind of basic but frequent and common absolute value equations. And remember to like and share, subscribe to my channel if you haven't already. And we'll see you guys later. Bye.